parametric coordinates, another way of describing our functions. Now, we're used to using Cartesian form. So we represent the function with one equation, and the points are represented by two numbers, an x value and a y value. Parametrics flips that idea. So parametric, the curve is described by two equations. One equation for the x value, one equation for the y value. But then the point is just described by one number, which is the parameter. Now parametrics, basically the name is saying a pair of measures. We have one measure for the x value, one measure for the y value. Again, let's use good old parabola again. Y equals x squared. That would be the Cartesian equation we're used to seeing. Now there's different ways I could write parametrics. One way could be something like this. X equals t on 2, y equals t squared on 4. Would represent the same curve. They're the parametric equations. So my point over here on the left, negative 1, 1, Cartesian coordinates, its parameter would simply be t equals negative 2. Because if I substituted in to my x equation and y equation, I would come up with x equals negative 1 and y equals 1. I would still get the same point. That's the parameter. T is the parameter. Minus half a quarter would be equivalent to t equals negative 1. The origin, t equals 0, and so on. So every point still can be uniquely described, but just with a single number. Well, how do we then work out what the equation is? So if I've got it in parametric form and I want to change it to a Cartesian equation, really it just becomes an elimination method, like simultaneous equations. You want to get rid of the parameter. You want to eliminate it. So here we go. We've got a curve. It has an equation, x equals 2t plus 1, y equals 3t minus 2. We want to show that this curve is in fact a straight line. We eliminate the parameter. We'll make t the subject of one of those. It doesn't really matter which one. I'll use x, so t is a half of x minus 1. Substitute it into the other one. We've eliminated the t. I now have an equation with just y and x. We've got the Cartesian equation, and we can easily show that, oh yeah, look at that, that's a linear function. It is a straight line. What would something like this look like then? X equals 2 plus cos theta, y equals 1 plus sine theta. I want to eliminate the theta. This is where trig identities would come in handy. You might recall this trig identity. Sine squared plus cos squared is always equal to 1. What I'll do is I'll actually make the parameter the subject of both of these, but not theta. In the first one I'll make cos theta the subject, and in the second one I'll make sine theta the subject. I can substitute that into the trig identity, and that will eliminate. So x minus 2 squared plus y minus 1 squared equals 1. I don't really need to go any further because that I recognise. That's a circle. So we've got a circle, its centre is 2, 1, its radius is 1. What about if x was sine theta and y was sine 2 theta? Now they've asked us to complete a table of values for all these different degrees. There we go. There's my table completed. It's the curve. We'll plot all those points that they just said. So here they all come. Still not really sure what that's going to look like. Well, what it looks like, it ends up that shape. There's x equals sine theta, y equals sine 2 thetas. If you're unsure, you would just be plotting more points until the shape emerges. So what's the Cartesian equation? Well, for that I need another trig relationship, and that's this one that says sine 2 theta is 2 sine theta cos theta. Now I can substitute in. I've created a triangle there. I know sine theta is x, so x on 1, which means the third side must be the square root of 1 minus x squared. I can now just read off that triangle. So y is 2 sine theta cos theta. So substituting in, we get 2x root 1 minus x squared. Another way of writing that, y squared is 4x squared 1 minus x squared. Now why do that? Well, because that's not going to be the complete shape. This complete shape here actually has plus or minus square roots involved. So I square it out. Get rid of that square root sign and I get a nice one. It's like I guess it's like our semicircle. That would just be y equals the square root of 1 minus x squared. To get the full circle, you'd have to square both sides. So to get this complete shape, I had to square both sides. But there's the equation for that lovely curve. 4x to the power of 4 minus 4x squared plus y squared is equal to 0. Okay, and that shall do us.